welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. I'm Alice, host of House of ZK Radio and also education lead at ZKM. Today I'm joined here with our guests, Muthu, CTO at Ligero, and Carmit, who is chief cryptographer at Ligero. We're really excited to have you here today, both of you, and thank you so much for being here.
Thanks, Alice.
Yeah, thank you for having us.
Thank you. Wondering if we can first start off with some introductions. Very curious to hear how you both got into the ZK space, and I know you both have academic backgrounds as well.
For sure, I can go first. I am an associate professor at Georgetown University, currently on leave. Trying to bootstrap our startup Ligero. My background: I did my PhD in cryptography at Cornell. Did a postdoc at Courant Institute NYU, and then I was a professor at University of Rochester for a decade. And recently, I moved to Georgetown University right after COVID, work alongside Justin Thaler, who's also in the ZK space. I want to say I started off as, I was motivated more by theory. I studied a lot about composition of cryptographic protocols, zero knowledge proofs, multiparty computation. One of these works required zero knowledge with very specific qualities. And in that paper, we used MPC and the head approach to solve it. But then we realized, hey, like, why not we implement it? And then I had a student who was, he was pursuing theoretical research, but he was like, okay, let me try to implement it. And that's how Ligero was published back in 2017. I should say that almost most of my work, more than half of my works, probably has been with Carmit. So that you can assume by default. I'll give it to Carmit.
Yeah, so I have a very similar background, academic background to Muthu. I did my PhD at Bar-Ilan University. My advisor was Yehuda Lindell, and I've been working on cryptography, secure computation, zero knowledge persistence for the past two decades. For quite a long time, we also had winter schools at Bar-Ilan, and we had the cyber center. I was also the deputy director of the cyber center, and we've been living and breathing zero knowledge proofs for a long time, much before it became so famous and people kind of used it for blockchains and for other applications. So yeah, and at some point me and Muthu joined forces academically, also in the company, and here we are.
Nice. And it seems like both of you two have been involved in the space for quite some time. Carmit, you just mentioned around 2 decades, and Muthu, you were originally more working a lot towards the theory side, and you mentioned with ZK, MPC, looking at the composition of different cryptographic protocols. Very curious to hear about how you both have seen the ZK space specifically evolve over the years. How would you compare the space when you first we're looking into it to now? Were there any kinds of challenges in the past that have been addressed today, or are there any kinds of new challenges that we haven't seen before that we should be prioritizing now? Any kinds of predictions for potential challenges that come in the future? Just curious to hear more about how you have seen the space evolve.
Zero knowledge proofs, they were invented in the 80s. We knew the potential of zero knowledge back in the 80s. In the beginning, it was more about feasibility. What can you do with zero knowledge? What's the limit, like from the theory standpoint, what you can do? I do want to say that in 2000, there were works both by Jens Groth. I want to say more 2000 to 2010 in this period of time. works by Jens Groth and his collaborators, as well as Yuval Ishai from Technion University and his collaborators, where they were trying to do different things. I want to say on one side they were trying to construct non-interactive zero-knowledge proof systems, and on the other side, trying to connect zero-knowledge proof systems to multi-party computation. And something very nice, I want to say, came out of both these works that is still now, kind of bread and butter to what we do today in zero knowledge. At that time, I mean, when these papers came out, it was still of only theoretical significance. But there were certain key elements that was focused on in these works that, gave it the potential that it could be implementable in the future. And fast forward to blockchain, Zcash, etc. I want to say, these non-interactive zero-knowledge systems evolved into, I want to say, ZK snarks, which have an additional property to non-interactive zero-knowledge, which is succinct verification. And I want to say, gave birth to one of the first, I want to say, um, application that got a lot of attention, which was Zcash. It was around that time that we got into implementing our first system, which was Ligero. The challenges with the zero knowledge system used in the Zcash was, I mean, this is well known, and at that time it was about prover complexity, it was about trusted setup. And when we published Ligero, we realized that these were the bottlenecks we were solving. I mean, we wanted to implement a practical zero knowledge system, but the motivation at that point of time was that, hey, this can solve some of the key issues that you have in Zcash. Actually, the Ligero system, in many aspects, is similar to Stark's, Aurora, etc. In terms of it uses only hash functions, post-quantum. You can view it as a polynomial IOP, etc. Um, Ligero was, although published prior to Stark's in 2017. The way I've seen the ZK evolve is initially the bottleneck was about prover time. And you would see a flurry of papers that were trying to improve the prover time of zero knowledge. And after that, once this was improved considerably, the next was about representation. Hey, do I need circuits? Can I write it in a higher level language? And give birth to what I call ZKVMs. But then, once you have crossed that milestone, the question is, hey, what's the next bottleneck? And really, the next bottleneck is memory. And maybe that's one way to put it, but I'd really say it's about the hardware resources to build zero knowledge. But the bottleneck specifically being memory. In fact, the first version, the Stone Prover, and I don't know how much the Stu Prover, but the Stone Prover required terabytes of RAM to build their zero knowledge system. And many of the ZK systems today, use different ideas to reduce it, but memory still is a bottleneck. And this, I think, is going to be sort of the next frontier in terms of ZK. The challenge is to bring down the resources. And the reason really is that the systems today, like, you take like what RISC-0, Succinct, etc. are doing, they can run like you want certain throughput. If you give sufficient hardware, sufficient 4090s or 5090s, they can get you the throughput with some amount of latency, but they can get you this, right? But the question is, for many of these applications, you cannot afford to, delegate your proof. You cannot afford to even employ such a system. And one of the things that we've been trying to do with Ligero, it is lightweight. And to maybe summarize a little bit here is that Ligero can offer similar throughputs to all these systems, but with much, much less hardware. Kermit.
Yeah, I want to add maybe a few points. First, I want to say that today, many times when people say ZK, they don't really mean the privacy or the private aspect. They mean scalability, succinctness, and it is maybe one challenge to explain, educate people that zero knowledge is for most part, this is we mean privacy. This is very important. There are many, I think, different systems or products that people develop. They call them ZK something, but they don't have any privacy behind it, and it also kind of confuses people. So this is one aspect. I think another aspect is to the overhead or the gap that is required to enter this world of ZK for developers, engineers, is very high. The bar is very high because these systems are quite complicated. They require it's not just I mean, it's beyond just coding. You really need to understand some cryptography and how these protocols work. So if you code them, you definitely need to make sure you're not missing anything or changing or optimizing something and then breaking security. And as academic, I think our goal is to really make this knowledge, we believe in common knowledge. We want to ensure that this knowledge is accessible. So I guess this is part of our goal, helping the community really gaining access or easier access to this knowledge. And maybe my last point, and this is really in a broader sense, you've been talking about future challenges. I think we are in an era where we kind of trust the experts, meaning we tell people we are the experts, trust us, these systems are secure. But I think that in the future we would really like to develop some tools, automated tools, that will help people to take the code of a system, and the tool will help them to understand that the system is correct and is secure. This is kind of a longer term goal, but definitely it's a healthy process I guess in every area.
And I really like how you, Carmit and Muthu, kind of addressed two different areas. So Muthu, you were speaking more about some of the technical challenges. First, it was more about the feasibility side, reducing the prover time, and then going into the transition from this representation from circuit-based to ZK VMs, and then now we're looking to bring down the resources when it comes to hardware, and specifically on the memory side. And I like how, Carmi, you mentioned about the challenges with the developer experience, and then also how ZK is used a lot today to mean succinctness as opposed to privacy. So there's that education aspect there too. And just going into some more details about the Ligero prover itself. Muthu, you mentioned that one of your goals when building this was to build a practical ZK system without a trusted setup. And for Ligero specifically, you were able to achieve similar throughput compared to other systems, but with less hardware requirements. Just curious to hear more about some of the other design considerations that you and the team had to make. So, for example, I know that Ligero really focuses on the MPC in the head paradigm as opposed to applying some traditional like PCP techniques that are used in a lot of Stark-based systems. So wondering if you can speak a little bit more about that and kind of the intentions and the motivations that the team made in making these types of design considerations.
Definitely. The one of the nice things in this paradigm of MPC in the head is when you want certain properties of the zero knowledge system, you ask, hey, are there corresponding properties in the underlying MPC protocol that if I instantiated that I would get automatically? And I want to say a lot of our thinking when we design these ZK systems come from there. And there's like wealth of research work that's gone into MPC. And the kind of MPC we're talking about is something called honest majority MPC that does not require cryptographic assumptions. It's information theoretic for the most part. And again, this has been studied, I want to say, since the 80s. But one aspect I want to tell you here is that MPC is about privacy. It's about doing computation with maximal privacy. So one feature that you would get when I do this MPC in the head compilation is privacy. And I emphasize this because Karmit and we come from, hey, we want ZK for privacy more than ZK for succinctness. Succinctness is great. You should have it. But we want ZK for privacy. And I want to say, if you trace history between cryptography and complexity theory on how, proof systems to probabilistically checkable proofs to zero knowledge, there has been a back and forth. And just want to mention anecdotally here, like when I was a PhD student at Cornell, the the theory, like the CS department had invited Elie Ben-Sasson to give a seminar, and he talked about PCPs. He talked about efficient PCPs, and he talked about, hey, I'm going to make this efficient. And one of the things that Starkware really has done is they have done this. Like they have brought PCP. One of the important aspects of PCP is succinct verification through Starks. And I also want to say, for example, there are other proof systems like GKR and SumCheck, which also are less privacy but more succinct verification that's been leveraged by several works, including the works of Justin Thaler and Jolt and Lasso, where again, I want to say succinct verification prioritized over privacy. For us, I think choosing MPC in the head and refining that to give succinct verification, we are trying to get privacy plus that. And, privacy first and succinct verification next. But that being said, I want to say the space has really rapidly progressed. There are better abstractions. You don't need to think of MPC in the head or GKR or SumCheck. You can think of polynomial IOPs, right? Like this is kind of something that could abstract most systems. And Ligero is an instantiation of this with different trade-off metrics compared to the other systems.
Yeah, I could just add, I mean, as academics, I guess, Muthu mentioned Elie Ben-Sasson, we kind of went through, I guess, a similar process. We started as researchers, we explored this paradigm of MPC in the head. Even before we explored it in the context of zero knowledge, we came from the area of MPC, which is secure computation, a generalization of zero knowledge. And we've been working a lot both on the theory and the practical sides of research to understand and kind of push the boundaries of this paradigm. And at some point, yeah, we also came up with this Ligero's proof system, and it was a paper published. And yeah, I mean, I don't think at that point we envisioned we will be today at this point where the system will be kind of a very, I guess, some sort of a breakthrough in understanding in proof systems with all the trade-offs that it can introduce. So it really came from, I guess, like other stories from the theory side and pushed all the way to the practical regime. And yeah, I think this is a very nice where I think how much we could actually push that. And I just want to say that really this MPC in the head this is not the end of story where we are, because it's so versatile. You can really instantiate it with different cryptographic tools. So I guess we are still yet to explore how much further we can push the limitations and boundaries of the Ligero system.
Absolutely, and really appreciate how you mentioned that kind of flexibility part as well, how it can potentially be instantiated with other tools. And as you mentioned, Muthu, I really liked how you are treating privacy as this first-class citizen when building When building Ligero's system, you mentioned that different protocols, they may prioritize succinctness over privacy, but with Ligero specifically, you're both trying to address both properties, but treating privacy as kind of the first one. So really like those points that you made. Also wanted to transition our discussion into the Lihetron ZK. So I'm wondering how it compares to the originally published Ligero protocol that we were just speaking about. And it would also be really great if you could mention some of the motivations behind some of the extensions and some of the changes that were made.
Definitely. We published the Ligero system in 2017, and soon after, we actually, I mean, Carmit and I, we said, hey, like, why don't we start pursuing real use cases? We formed the company with two more co-founders of ours, more business savvy co-founders. Uh, we wanted to look for privacy use cases. And we had at that time implementations of both zero knowledge and multi-party computation. We thought that multi-party computation had a lot of potentials in auctions, financial markets, both TradFi as well as in the crypto space. And for like I want to say 4 or 5 years, we built like three MPC products that if it matters, we can tell you what they were. But in the same time frame, we secured a grant from DARPA, which is this army agency in the United States. We were a subcontractor to another company called Stealth Software Technologies, which is again another MPC company that's been there for a very long time. Um, in this grant, we were tasked with improving zero knowledge systems. And the goal was we needed to scale zero knowledge to trillions of gates on commodity hardware. That was one challenge. The other challenge was that there were many teams participating, and we needed to find a common IR or an intermediate representation that would work with a diverse set of backends. Now, I want to say the former challenge, like this DARPA program was amazing. The amount of research output that came from this was just incredible, and the amount of implementations that came out was incredible. But the task of finding an intermediate representation that works for everyone, I don't think was that successful. At the end of it, it was sort of a little more sophisticated version of how we would still write circuits. Maybe I'm a bit harsh about it. But coming more to where we came was that, hey, we needed to, if you want to solve trillions of gates on a laptop, using a ZK snark. One difference I want to make is most of the other teams that participated in DARPA, they didn't worry about the non-interactive or public verifiability part. They were fine with interactive, which cannot directly be used in blockchain. But we were like, we want it to be still a ZK snark. So we had to solve the memory efficiency bottleneck. Otherwise, you can't run trillions of gates on a laptop. So the first thing we did actually, Karmit and I, academics, theoreticians, ours is a hash-based system. Can we prove upper and lower bounds? We had a paper where we actually did prove that, hey, there is a trade-off you have to play between proof length and memory. If you want a hash-based system and just being a little technical without recursive composition and without public key assumptions, and I can tell you why we made those assumptions, but if you keep those assumptions, then there is a trade-off. You cannot get very short proofs with less memory. And in that paper, we had both a lower bound saying what cannot be achieved and an upper bound meeting this. And it was a variant of the Ligero system, but it was more asymptotic, meaning that I don't think there was something that anyone would implement it. But while we were doing this, we also understood, hey, we can make this practical. So that gave birth to, hey, like we want a memory efficient version of the Ligero system. But this doesn't still solve what IR to use. And here I want to introduce our chief architect, Ruhan Wang. He went and he is the most amazing engineer that we have. He actually went and studied the different IRs and picked WebAssembly as the intermediate representation. All the credit goes to him to have picked this because it is low level enough that there are few instructions that you have to implement, but it does still keep a lot of the semantics. blocks, loops, etc., garbage collection that we can use should we build a memory efficient prover. So putting these two together, we solved this, and this was the Ligatron system that was published last year in IEEE Security and Privacy. But although I should tell you, the first version of the Ligatron system under the DARPA program, we had implemented it in 2022. And really, I want to say that once we built it, the first question I asked, the engineer was, "Look, we are memory efficient. We should run from a browser." And he took a week. He cross-compiled our C++ code to WebAssembly. I mean, this is to run it on a browser, and we were able to run it on the browser. And I want to say the rest is history because from there we realized that this is going to have a potential because client-side proving is going to be crucial in bringing ZK mainstream.
Yeah, I could add that it all started from a question that we asked ourselves when comparing proof systems. It's not enough to just compare the running time. You really want to understand what are the resources consumed by the prover. So, what is the memory consumption? How much hardware do I really need to access while generating the proof? And that led us to this this path of understanding this trade-off between memory and running time, which, I mean, Muthu mentioned this lower bound. In that sense, Ligero is really optimal in the trade-off that introduces, and the practical path of actually making it run from the browser. So I guess this is another story or direction that came from emerged from a theoretical work that made us realize what would be the right way to go, and while asking ourselves what's the right way to compare between two proof systems.
Got it. And you mentioned, both of you mentioned that trade-off between proof length and memory. And Carmit, you also mentioned it's not just enough to consider the writing time, but also the amount of resources that are being consumed as well. And Muthu, you mentioned that WebAssembly, the motivation behind that was it to be used to create this memory efficient prover. You mentioned that there are fewer instructions that you have to implement, but at the same time, be able to maintain a lot of the semantics to create a more memory efficient system. But in addition to that side, I'm wondering in incorporating WebAssembly, and you also mentioned that Ligero is also browser-based as well. How does this affect the overall end developer experience, especially as Ligero offers this browser-native platform, and the Ligero team also really advocates for that plug-and-play adoption or implementation, as opposed to, say, using tool chains or custom compilers like what a lot of existing solutions offer. So very curious to hear about how this affects the end developer's experience, and also any kinds of implications you see for, say, lowering the barrier of entry for people who want to build ZK applications or developing any kinds of real-world applications as well.
Sure. The birth of ZK VMs, like with RISC-0, Succinct, and other companies, already has moved this needle, really to a point where DevX is getting far more easier. You don't need to learn specific languages, CIRCOM, Caro, or to build zero-knowledge systems. When we did the Ligatron system, actually, we were just very focused on the memory efficiency. But, clever as my engineer is, he already had this idea that, hey, look, once you do WebAssembly, like you can have any of these languages that compile to it, C, C++, Rust, etc. And as we were pivoting from MPC to zero knowledge, our sort of vision got clear, right? We want to make this ZK more useful, more usable. ZKVM is the first step in this. And once we got our thing to run from a browser, the next step was really obvious to us. Like, if you can run this from a browser, like you can have people code your applications in a browser. We're not talking about like, C, C++ code at the moment, at least like running to thousands of lines of code. But, like simple applications. I want to verify a signature, verify a Merkle tree, etc. These programs can be easily written. The C code or Rust code can be written, and now you could use the same browser interface for people to develop this. And we did this. We had a very rudimentary way of like, you copy paste your code, you do it like this was the first version, I want to say like maybe a year and a half back. But I went around presenting this and I got amazing reaction. People couldn't believe that now it is so easy to do this, right? Not that hackers can do anything, like they are amazing. You give any piece of code, they'll compile it on any machine, run it, etc. But you want to bring a wider developer community, this needs to be easier. So that's one step, right? One step is about first developing these applications. But the second step, which I want to say, I'll just be honest, we don't know yet, which is very important, is how do we plug these systems into use cases? The form factor, how do we assemble these things? Already, I want to say that on our platform, you can create an application and you can say download, and you will get a bunch of files. These files are very small, by the way, like, order of megabytes. And the reason I'm saying this is we spoke to someone who has been using CIRCOM for a very long time, and they said, "What you're like?" Because for them the trusted setup is already gigabytes, and they're like, "Your whole code base that you want to run is a few megabytes." What we want to know more and understand more, and we're talking to all the people that are using, and there's like so many people leveraging zero knowledge, I want to say, and want to do it for privacy. We want to make it more plug and play. We want to understand how is it easy for you to integrate uh, the ZK into your system.
Yeah, I guess this is really is dictated with the philosophy behind our, I mean, one of our goals to make this usable for as large community as possible, make it easier for people to be able to use these tools without really spending so much time understanding how the zero knowledge protocols work, making this knowledge accessible and again these tools usable. So as I mean, the more we actually we came across all this ZKVM and the fact that you can actually compile pretty much any language into WASM. It really fit into our goal, like our future goals, and we were really happy that from the feedback we received from the community. So
Yeah, absolutely. And just the ability for compiling almost any kind of higher level language to WebAssembly, I think is pretty powerful. Developers don't really have to, say, learn new kinds of ZK-based, like domain-specific languages. Instead, they can use languages that they're already familiar with and be able to create programs and generate proofs from them. So I think that kind of goal that you both have in seeing how we can build this wider developer community, it's great to hear that. And just into one of your points on, I think, Muthu, you said before, the main question now is how do we plug these systems into different use cases? And you also mentioned very briefly that you see client-side proving as essential to bringing ZK more mainstream. Wondering if you can talk about some of the differences between client-side proving and server-side proving, which is both what Ligero offers, and just from like a user and application perspective, in what scenarios would you choose one over the other? And I know that the Ligero team is focusing a lot on privacy-preserving identity-based use cases. So I was wondering if you could speak a little bit more about that.
For sure. So, I mean, instead of client side and server side, I think the way we want to look at it is privacy for individuals and privacy for organizations. And the question really comes down to where is your sensitive data, right? For an organization, it's a server. For users, it's your laptop or your phone. Now, if you want to develop ZK for privacy, you want the ZK to be generated on the device you carry your sensitive data. Now, if ZK is scalable to run on the device where the sensitive data rests, you don't have to make a trade-off. You don't need to send it to a trusted execution environment on a remote server. You don't need to use like MPC or co-snarks to do it. You can get the privacy that you need from the device where you're already using other measures to protect the sensitive information. I'm not saying that TE and MPC are not useful, etc. I just want to say you don't have to make that. There are security trade-offs you're making uh, while employing those approaches. So when it comes to privacy for individuals, I would think like for identity related, this is the top application I would think you want to run it from your mobile phone. And once we could run it from a browser, I want to say like a Safari browser, for example, will give you only 1 GB of RAM. Now you can run it from your mobile phone, from a browser on your mobile phone. You don't even need to create an app. So I want to say when we managed to do it on a browser on a laptop, we kind of got also doing it on a mobile phone for free. At Ligero, the way we are focusing this is maybe I want to just give just 2 minutes sort of. I want to tell you from a product side where we are looking at the use cases and our vision. To me, I mean, blockchain is this amazing phenomenon that's going to change, the way we do things. And people believing this, I want to say that, there is some point in future where the world is on blockchain. There is a crypto wallet in every phone. But the path to getting this, I want to say there are going to be points where, let's say, enterprise is going to come to blockchain, like, full-fledged in terms of their operations, as well as government and regulation. Now, I'm sure there's a lot of politics in terms of regulation, etc. I'm going to keep that aside, but I do believe that there is a way to bring, just pragmatically speaking, regulation and enterprise to blockchains, and I think ZK is going to be the conduit to getting this done. And the focus we are going to do is we want to build the infrastructure that's going to be useful for this. And two pieces of this I want to say is one, privacy. And this is something that we're going to enable through something called ZK Validium. The second is compliance. And I want to say that this is, at least if you talk to a lot of people, everyone cares about privacy, but are they want it solved today? And the answer will be, it's not clear. They're like, yes, I do want it eventually, so forth. But compliance is something they do need today. If you are an on-ramper, off-ramper, fiat to crypto, etc., you're moving, assets across borders, you have to, meet compliance. What we are trying to, at least our vision is about doing self-sovereign compliance. What we mean by this is that whoever needs to establish compliance doesn't have to be with the organization, it can go to the customer. Once ZK becomes seamless, lightweight, once we understand what is this plug and play, people will be able to prove compliance. And maybe this is wishful thinking, but I do want to point out that, like, we all heard about the recent Coinbase attack. Now, they had to hold data. And this is not their fault that they're holding data. Regulation, KYC, AML requires them to hold data. But if we are able to move this to the users, to the customers to prove their KYC, their compliance, their AML compliance, now the attack vector becomes much harder because it's not in one place. It's not like an attacker can go to one repository and get all this data, right? So I think solving compliance, solving privacy, I think is a key piece to this blockchain utopia uh, we all believe in.
Muthu mentions enterprises and individuals, which have two different, these are two sets of use cases with very, very different requirements. And I don't think there are many types of technologies that can be optimized to satisfy both types of use cases. And this comes from the power, the great power of MPC in the head abstraction technology, which can really, as I was mentioned before, versatile and can really be used to answer different type of use cases.
Absolutely, and really liked hearing that Ligero's thinking of extending beyond just these identity use case to a broader vision in terms of self-sovereign compliance. So really great to see the extensibility of these use cases here. And wanted to also speak a bit about Ligero's integration with Google. So I'm very curious to hear some of the implications that Google's implementation with the Ligero protocol has and how that affects the end user's experience with Google's digital wallet. And maybe just as some context, if you two could speak about the status quo today for just identity-based verification, how we deal with identity verification today, and how that may be changed with this new integration.
For sure. I want to say that maybe first just to clear some of the things between Ligero and Google. First thing I want to say is that Google has incorporated into its wallet a ZKP system that allows to prove identity using, let's say, a digital driver's license. Say in the US, there are 11 states that issue digital driver's license. This is something in the MDL format, which has this ISO standard. If you have this can be put into your Google wallet and you can build a zero knowledge system. Now, the zero knowledge system that they implemented, Ligero is part of the stack. It's not the only part that is there. It's actually a combination of Ligero and GKR Sumcheck. I mean, I've known about this work because I know the cryptographers behind building this team. And one of the things that they mentioned is that they tried different, they wanted, I mean, look, now that we know this abstraction of polynomial IOP, polynomial commitment, and, constraint proving, etc., they hunted for the best polynomial commitment scheme that would give them performance on a low-end device like a mobile phone, because they want this integrated. And we didn't know this at the time, but, after it was done, they told me that, hey, the Ligero polynomial commitment scheme was had the best performance over this, and that's why we used it for the polynomial commitment scheme. The going to the identity part of this, Europe is trying to standardize their digital ID. There is this EU ID effort that they are, trying to get all the EU member states to accept. I think some form of it is going to, probably get into law. Again, I don't know the exact details, but the current version actually doesn't specify zero knowledge. They have some privacy preserving mechanism, but it really doesn't rise to the standards of security we know today. And a lot of cryptographers in Europe as well as US have, convinced them you need to use zero knowledge. And I think this is going to be an important step towards getting privacy for every individual. I mean, we talk about this example of, hey, like I want to go into a bar and say that I'm over 21 years or over 18 years. You can do this now with the with this Google Wallet integration. I want to say how we are thinking about this. They use this combination of, I want to say Ligero and GKR, but they actually used the original publication from 2017. Right, they've used that architecture. They haven't leveraged the memory efficient Ligatron system. We are going to build this not circuit but a program that will tell you, hey, here is the format of your whatever license or credential. here is the signature scheme. It could be ECDSA, EDDSA, elliptic curve based, or you want post-quantum based signatures. You should be able to build this on our platform and verify it. You could generate these proof from the browser, and I think with the Ligatron system, we will be able to meet their performance. And this is something that we do want to showcase using our platform first, but it also fits as a piece in the puzzle of our compliance regulation, KYC, AML. Once you have these digital credentials, you can now prove them, you can use them for all these applications.
Yeah, I could just add that all the effort by Google and also the standardization effort, these are good news in general. That it shows that society starts to care about privacy. Um, I mean, both in Europe, in the US, the fact that a company like Google is deploying such tools, I guess these are good news in even in a broader sense that they also care about privacy. So we are happy on multiple levels.
Absolutely. And also curious to hear about if there are any specific trade-offs for this type of implementation. I know that the Ligero team has previously spoken about its use in a restricted data model. So wanted to hear more about some of the trade-offs that had to be considered in this process. And also just on the vision side, how you see this implementation tying into Ligero's longer-term vision.
The I want to say the Google's implementation is like the circuit is more or less fixed. There are some parameters you can play with, but it is more in the circuit model than in the ZKVM model. So if you have newer applications, then you will have to go back to your circuit board and build the circuit to implement it and test it, etc. One of the things we are trying to do with our system is this. This is the flexibility you're going to get. What kind of predicates? Maybe you have multiple credentials you want to jointly analyze these things. The uh, the second thing is that we want to uh, open up our platform. We have this marketplace. We want to open it up for developers. I mean, we know a lot about what's going on in the United States, and what kind of predicates, what kind of AML reporting, and we are developing in-house these predicates on our platform. But we want to see our marketplace as a place where different jurisdictions, different countries, whatever predicates they need, they will develop it on our marketplace. And what we want to do is that we want to give the seamless integration they can do once they build these applications in our marketplace. So when we think of these regulatory compliance, we are not just thinking about the US. We know more about how it goes, how it is in the US. But once we have this integration, we hope that this in a decentralized way will evolve, where people from different jurisdiction will incorporate their own sort of compliance measures.
Got it. Absolutely. And I think that this is really the first step of a kind of longer term goal that we have. So it's very impressive to see all of these strides being made. And just as a last question before we close today's session, curious to hear what's next on Ligero's roadmap and how any kinds of developers in the audience can get more involved.
Uh, I think one important piece of making our technology more useful is a more comprehensive SDK. We don't want users to code the hash function or the signatures, etc. We want to put this part of the SDK. And one of our vision is, of course, to use the marketplace as uh, a place where people will implement all these things, and we can see it, refine it, and put it into the SDK so that everyone else can use. I think this is going to be important for people to use, and it's not just cryptographic things, it's also parsing. I want to say most of these client side proving verifiable credentials, there is parsing, there is the cryptography, and parsing is not easy. Like you need to do regex, etc. So there are these tools, APIs, etc., that we want to put in our platform, and we want developers to come and build this on our platform to give a rich SDK so that it's going to be much more easier. I gave a talk this Monday at the ZK Summit, and it was about vibe coding. I'll just maybe tell one sentence about this, right? We all have ZK VMs. You can code in high level language. Vibe coding is this philosophy, and it was coined by Andrei Karpathy, that you don't need to touch your keyboard. You can build an end-to-end application just talking to your laptop, get LLMs to generate things, use cursor to, integrate and build it. Why can't we do this with ZK? You should be able to do it with ZK. You have ZK VMs. So I learned about this vibe coding just 4 or 5 months back, and I started building applications. It was pointed to me by a friend of mine who was building apps for his kid. So I was also like, okay, I have a 5-year-old kid. I want to teach her math, and I started building it. But then I was like, okay, we need to do this for ZK. And so I was able to do like Fibonacci, basic like text redaction, some edit distance computations. I was able to ask an LLM, talk to an LLM, generate the code, copy it into our platform, and build a ZK application. And I think we need to evolve with how we are, how code is also evolving in the space. And I think we are at a point where we can do this. That being said, I will caveat everyone, be careful if you're using LLMs, if it hallucinates, generates wrong predicates. I mean, it's a security issue, but I do think that it's going to become very easy to build these applications. And I will tell you, this will be possible if we have this. I think we can have a Copilot extension to our platform where people could just talk to our platform and generate code. We should be able to recreate the circuit that the Google Wallet application did by just speaking to our platform. This, I will tell you, is possible.
Yes, and alongside this major efforts of implementations, we are also working on the theoretical part, trying to really improve the mathematical aspects of the proof systems. Everything is backed up with complete security proofs, because we're academics, and also this is very important that we deliver. We stand behind. We have a security statement behind our system. So the effort is going in two paths.
Yeah, it's great to hear all the developments on the security side, and then also move through your vision for applying vibe coding to ZK. Now individuals can really just focus on, we see a trend where they can just focus on the business logic of their applications as opposed to having to devote all their efforts to building those underlying circuits and thinking about the cryptography behind ZK. But really, I see this as a tremendous stride into greater adoption, both on the developer fronts and then also on the application fronts as well. And also really great to hear overall how you both are, in addition to these developments, thinking about how we can plug these systems into use cases and how you're working on extending your use cases from just those privacy identity related to self-sovereign compliance. So all really great to hear, and really enjoyed the discussion today and all of your insights. Thank you so much for joining us.
Thank you for having us.
Thank you.